In section 2.7, part 2, we're looking at examples of finding the values of variables when we have linear pairs and vertical angles. Remember that linear pairs are angles next to each other on a line. They have to be supplementary or add to 180, whereas vertical angles are congruent. And those two facts are going to help us find the values of x and y in an example like this. The first thing you need to do is identify where the angles are that have x and where the angles are that have y. And if you notice here, the two angles that have x in them are here and here. What kind of angles are those? Well, those are vertical angles. And you're thinking, in this case, what do you know about vertical angles? Well, vertical angles are congruent, aren't they? So what do you know about these two expressions with x? You can set them equal because you know their measures are equal, those angles are congruent. So in this case, I know that the 10x minus 4, which is my first angle measure, has to be equal to or the same as this angle measure of 6 times the quantity x plus 2. And now we can do some algebra here to solve for x. These two are equal, I distribute, I get 10x minus 4 equals 6x plus 12. And I have x's on both sides. I would probably subtract 6x here, get rid of this. 10x minus 6x is 4x. Minus that 4 equals just 12 on that side. Add 4 on both sides, 4x equals 16, divide by 4, and I find out that x is 4. Okay. And then take a look at where the y's are. I have a y here and a y here. Once again, vertical angles. They are across from each other when these lines intersect. I know they're congruent or equal, so I know that 16y should be equal to or the same as this angle of 18y minus 18. From here, I have to solve for that y variable. There are y's on both sides. I would subtract 18y, and 16y minus 18y is actually negative 2y equals, I just have negative 18 on this side, divide by negative 2. And y equals 9. Oops, I don't mean that to look like a negative there. So looking at the fact that we had vertical angles with the same variable here, that's why I set them equal, because vertical angles are congruent. This is one example that you might see today. But another case that you might have is if the variables are not in vertical angles. For instance, if I take a look here, I look at the two angles that have an x expression in them. And I see an x here with 10x minus 10 degrees, and I see an x here with 4x plus 50 degrees. Now in this case, these are not vertical angles, they're angles that are next to each other on a line. These are a linear pair. And what do you know about linear pairs? You know that they are supplementary, or because they are two angles together on a line, they add up to 180 degrees. They're not congruent this time, they add to 180. So I know that 10x minus 10 and 4x plus 50, what do? They're not equal, but they add up to, or they total 180, because they're together on a line, and a straight line measures 180 degrees, and in this case I'm combining like terms. 10x and 4x is 14x, negative 10 and 50 is plus 40, that equals 180. I subtract 40 from both sides, 14x equals 140, I divide by 14 and I find out that x is 10. And then a similar thing with these two angles that have y in them. Again, a linear pair of angles. They're together on a line, therefore they should add up to 180. So I take the first angle, 5y plus 9, and the second angle, 6y minus 5. I add them together, and I know that they would total 180. Solve by combining like terms. 6y and 5y is 11y. Positive 9, negative 5 is positive 4, equals 180. 11y equals, I subtract 4, and I get 176. I take 176 divided by 11, and I get 16. So looking at solving for variables when you have Angles labeled, just check whether they are linear pairs and they add up to 180, or whether the angles of the same variable are vertical angles, and then they would be congruent.